Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The substrate is a quaternary carbon center at C1 of a cyclohexene ring bearing two ester groups, an acetate ester, CH3-CoO, i.e., the oxygen of the ring carbon is esterified with acetic acid, and a methoxycarbonyl ester, C, is equal to O, OCH3. There is also a methyl group at C6 and a double bond in the ring, C2-C3 position. Moving on to the next step. Lyl-4 is a strong reducing agent that reduces both esters to alcohols. The acetate ester, CH3-C, is equal to O-OC. Upon reduction, Lyl-4 cleaves the acyl-oxygen bond of an ester, reducing OC, is equal to O, CH3 to give O, the alkoxide alcohol on C1, and CH3CH2O, ethanol, which is washed away. So the OC is equal to O, CH3 group at C1 becomes O at C1. The methoxycarbonyl ester, C, is equal to O, OCH3. Upon reduction, Lyl-4 reduces C is equal to O, OCH3 to CH2O. So the C is equal to O, OCH3 group at C1 becomes CH2O. Moving on to the next step. After reduction of both ester groups, C1 bears an O group from acetate reduction, a CH2O group from methoxycarbonyl reduction, the methyl-bearing cyclohexene ring carbon connectivity, and the ring itself. The double bond in the ring is not affected by Lyl-4 under normal conditions. The methyl group at C6 remains. This gives 1-hydroxymethyl, 6-methyl-cyclohex, 2N1-ol, a cyclohexene ring with a double bond, methyl at C6 or at C1, tertiary alcohol, and a CH2O group at C1. And for the final step, option C shows a cyclohexene ring with double bond retained, methyl group on the ring, or at the quaternary carbon C1 and a CH2O substituent at C1. This matches exactly. A shows two O groups directly on C1, gemdiol, which would result from reduction of two carbonyl carbons directly attached to C1, not from an acetate ester reduction which gives O on C1 by cleavage, but does not give a second direct O from the methoxycarbonyl. Actually, option A lacks the CH2O, so it is wrong. B appears similar to C, but shows a fully saturated ring, no double bond, so the alkene has been reduced, which Lyl-4 does not do. D shows a ketone product, which is the opposite of reduction. Therefore, the correct answer is C. Therefore, the correct answer is option C.